I just wanted to show you this. This is something I'm putting together for, hang on, wrong thing on the background. There we go, that's there, that's there. This one. So the first few slides are pretty much the same. That's the same. This one I'm going to put on the YouTubes. That's the same. Something new in here. I've forgotten what it is. Oh, that's right. Yes. So just a few. I just want to work through an example of. I'm not muted, am I? No, I should be able to hear me, I hope. So how many bits do we need to make 4 subnets? Well, I borrow 2 bits because 2 to the power of 2. So this is what we started with, 192.168.1/24. And then if we borrow 2 bits, then we chop it up into 4 pieces. So how do each of those pieces look? So we've got to figure out how, we've got to calculate the host ranges. So we've got 0, 0, 0, 0, 0, 0, 0, 0 is all zeros. Then 0, 0, 0, 0, 0, 1 is 1, first usable. Then 0, 0, 1, 1, 1, 1, 1, 0 is 62, which is the last usable. And then 0, 0, 1, 1, 1, 1, 1 is the broadcast address, which is 63. So when we're calculating the host ranges, we just need to move that block of what we care about down to the next level, because the network ID is always zeros, the broadcast is always ones, the first usable is 1, and the last usable is 1, 1, 1, 1, 0. So 0, 1, 0, 0, 0, 64, 0, 1, 0, 0, 0, 0, 0, 1, 65, 0, 1, 1, 1, 1, 1, 1, 0 is 126, 0, 1, 1, 1, 1, 1, 1, 1 is 127. Then, sorry, I should look at the camera. Then the next subnet starts with 1, 0. So 1, 0, 0, 0, 0, 0 is 128. 1, 0, 0, 0, 0, 0, 0, 1 is 129. 1, 0, 1, 1, 1, 1, 1, 0 is 190. 1, 0, 1, 1, 1, 1 is 191. So we move on to the next subnet and we get 1, 1, 0, 0, 0, 0 is 192. 1, 1, 0, 0, 0, 0, 0, 1 is 193. 1, 1, 1, 1, 1, 1, 1, 0 is 254. And 1, 1, 1, 1, 1, 1, 1, 1 is 255. So that's the sort of, that's the following the flow of the, thank you. Yeah, I forgot. I always get lost when I get up to 12. So that's just borrowing 2 bits, because the host range is what helps you figure out that you're not doing any overlaps. That's the important thing. So sometimes it's quicker and easier to just calculate all the network IDs. I said this before in the presentation, 0, 64, 128, 192. So therefore, the host range for subnet 0 is 1 to 62. The host range for subnet, the second subnet, is 65 to 126, because 127 is a broadcast. The host range for the next subnet is 129 up to 190, because 191 is a broadcast. And then the host range for the next one is 193 to 254, which is pretty sure what I said on the previous slide. Yep, there it is. So think about it when you're subnetting. Think about just do all the subnets as network IDs, and then the host ranges have to fit in the gaps. I haven't. No, this is what I'm going to put this on the YouTubes tonight. So this is why this is you guys. I've done all of the because have you noticed the template's my network lunchbox template. So I haven't actually I'm going to record some proper audio tonight and put them up there. I'm just sort of running them past you. So we've done all this. This is the same. I think I've even used the same graphic, so I'll do it again just for fun, just in case you've forgotten. So don't borrow anything. 254 hosts. Borrow 1 bit, 2 subnets, 126. 2 bits is 4 and 62. 3 bits is 8 and 30. 4 bits is 16 and 14. 5 bits is 32 and 6. And 6 bits is 64 networks and 2 hosts per network. And I've also put the subnet mask and the side of notation there as well, just to show you the comparison. Because and then I've got the don't be crazy, don't be ridiculous, same slide as the other one. Now this is one thing I wanted to quickly touch on. Math is fun and I love math, but I want you guys to also, sometimes doing things by rote, you know, our primary school make us memorize things. Sometimes it really helps. So everyone, put down your coffee or your phone. Make sure you don't spill it or spill on yourself, and hold out your 2 hands like this, like exactly like a thing, and make 2 fists with the fingers facing up and your knuckles facing down. And repeat after me. So stick out your left thumb and say 128. Stick out your index finger and say 192. Stick out your middle finger and say 224. Stick out your ring finger of your left hand and say 240. Put your pinky out and say 248. And then the thumb on your right hand and say 252. So let's do it all again. Now this time, have a look at the whole screen and notice that on the right hand side, I've got the binary. See? 1, 0, 0, 0, 0 equals 128. 1, 1, 0, 0, 0, 0 equals 192. 1, 1, 1, 0, 0, 0 equals 224. 1, 1, 1, 1, 0, 0, 240. 1, 1, 1, 1, 0, 0, 248. And 1, 1, 1, 252. So, because you are going to be doing subnetting, you are going to be borrowing bits. So when I say Class C network, I've borrowed 3 bits. You don't have to sit down and do the math and say, what is 128 plus 64 plus 32? You just hold out your left hand and go thumb, index, middle, 224, done. So the subnet mask for 3 bits borrowed is 255, 255, 255, 224. So this is a little pattern that will help you memorize and help you be faster at calculating the subnet mask, because doing everything with a slash is fantastic, but when you actually go to program the equipment, you're going to need to put in the mask longhand. Or could be conversely, I could say, hey everybody, how many bits have I borrowed if the mask is 255, 255, 240.0? And you think to yourself, 240? How many ones is that? And you get out your left hand and you go bang, 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 bang. Oh, 4 bits. So this is going to help you actually memorizing. Just give yourself a little, you know, classic primary school memorize things by rote, and this really helps you out. So it's just a pattern: 128, 192, 224, 240, 248, 252. And that's the number of bits in the subnet mask, and that's what it's just binary to decimal conversion. So this is just a bit of a chart just to give you the flow. So from the bottom up, that's what we just did: 128, 192, 224, 240, 248, 252. And then from the top down is like the broadcast address, if you will, or how many, you know, what can you fit? 1, 3, 7, 15, 31, 63, 127. This is just a pattern of ones to sort of think about, because you'll get a feeling after a little while about what numbers feel like they're right and what numbers don't feel like they're right at all. All right, so that's the first one. That's going to be I'm going to put some proper audio on that tonight and put it. But this is what I really want to spend some time on today with you guys, because this is, let me just share my screen again. So, all right, here we go. Now, I don't know how I'm going to do this without having the chat open, but we'll figure it out somehow. Okay, so what is now VLSM? I just wanted to, oops, bring up the wrong thing. So variable length subnet masking. It's the same thing. What is how, blah, blah, blah. I've done this already. This is just a rehash of the previous slide. So 32 bits long, borrow, borrow, bits, bits, borrow, bits, borrow, bits. Same thing. Now, here's what's new. What happens when the subnet mask changes? That's what variable length subnet masking is. The subnet mask is not the same. But it's no need to panic because it is just subnetting is subnetting. So we get the, I was trying to look for a decent Fibonacci thing, but they had, they all had numbers on them and I didn't like them. So I like this shell. It's a similar sort of thing. So let's say I order a pizza. See, we're meant to be in the classroom, so I meant to do this as a class thing. We order a pizza and, sorry, just make sure. Good. So we order a pizza and the pizza arrives, but I'm really greedy. So I cut it in half and half is for me. So I take half and you all have to fight over the second half. So the biggest and strongest who grabs it and cuts it in half and keeps a quarter for themselves and then throws a quarter to the rest of you. You all have to fight over that quarter. So then you fight again, you cut it in half and you cut it in half again. Variable length subnet masking is quite literally just this. Whatever you've cut up, you cut it up again, and then you've got your you're cutting up, if that makes sense. So it's cut up. But it's always in the binary. The biggest thing I see is people, when they do VLSM, they say, oh, 10 PCs. So 10, you know, that's a few bits. So I can go from 1 to 14, 15 is a broadcast, and then I can start again at 16. Oh, how many do I need? Oh, I need 100. No, that doesn't work. Because you've already cut it up so small, you can't glue it back together. Once you cut a pizza up, you can't glue it back together. So when you do your cut, you got to cut. You cut it once, and that's cut. You can't cut it into quarters and then glue that quarter back together and make it a half again. So these are the labs for. This is the lab for today. So let me just bring it up so you can see it. I won't see that one. No, not that one. This one. So we're on this slide here, I'm pretty sure. Come on, pay attention. Okay, so if I start typing, something happen? Yes, good. Okay, so the first thing we got to do, so this is a VLSM design. So this is one of the exercises straight out of the book today. So we're going to do it together, and so we all figure it out. So what I've done is I've broken it out into the binary, and I've got the math. So now the image is in the way, so we're going to get rid of it. So the first thing we need to do is we need to see how many networks we've got. So, oh, hang on, how can I make this? Oh, here we go. Okay, so I've made this so I can see the chat. Hang on, let me get rid of that so I can type. So, all right. So we've got this network. Now we've got 3 serial links. So the 3 serial links, we need two IP addresses each on each of those networks. So because we have to address everything, right? So what is the next amount of space? Just type in the chat or unmute yourself and talk. What is the next size network that we need to cater for? Yeah, it's meant to be. Because see how the number 2s are in the, so we're meant to look at the picture. So yeah, no, we've done the 3/30s. They're the first 3 2s. And see in the right-hand column, I've got hosts in purple. So they're the 3 networks we've got to cater for. What's the next one after that? Now 60, we'll work our way from the bottom up. So 60 is a bit big. We don't want to tackle that one quite yet because you've got to do it in order, and you'll see why there's madness in my method. All right, I'll give you the answer. It's 12, and there are 2 12s. There are 2 12s. Then there's a 28, and then there's a 60. So just triple check what I've written in purple over on the right-hand side. Have I got all of the networks? Are there any networks that I've missed? So I've got 1, 2, 3 serial links, which are 2 each. Then we have two 12s. Then we have a 28, and then we have a 60. Is everyone happy with that? Please type yes in the chat. Good. Okay. So we don't need the diagram anymore, right? Because we've got all the values off it. So now, so we've got 2, 2, 2, 12, 12, 28. So what we need to do is we need to calculate out how many bits do we need. So how many bits, what is the number of bits we need to cater for a network that's only too big? How many do we need? How many bits do we need left over in the host portion to cater for 2 bits? Let me just make sure that I've got the right settings so I can hear you if someone's talking. Is anyone talking? No. Devices. No, it's my headset set up right. Two. Okay, so good. So we need 2. Now, how many have we got? 3 of those, haven't we? So where I've put those X's, they're the host bits. They're the bits we need for the host portion. Okay. So how many? So let me just let's get rid of that. What do I need to do? Let's do this. Let's make a white paper. There we go. Now, all right. So how many bits do we need to fit 12? So we've got Damien's already answered. He's already preempted this, but so I'll write that in. So 4. You reckon? Does everyone agree that 4 is right? 1, 2, 3, 4. Maybe I'll turn a caps lock so I'm holding things down. So that is going to be, whoop. So we need 4 bits each for that. Now, how many bits do we need? Only need 2, but you end up need the first 2. So I'm not sure. No, so we'll get to that in a minute. No, in order for 12, if we need 4 bits to fit in. No, we need how many bits? How many fingers do you need to use to count to 12? In binary, you need 4. So it's not what equals 4. It's how many numbers we need to use. So how many bits do we need to fit 28? To fit 28 bits in. 5. People say 5. Pretty sure 5 is right. And last but not least, 60. How many bits do we need to fit in 60? 6. Most people say 6. Pretty sure you're right too. Oops. So let's just triple check our math. See, we haven't even done any math yet. We've just actually figured out what do we need to actually cater for these network sizes. So is everyone happy with that? Is everyone happy that this actually will let us fit in the networks? All right. So let's put in our masks. So if we've only got 2 bits left over, now someone already said it in the chat before, so I'm just going to type it. Oop, there we go. So, oops, no. All right. Now, so with only 2 bits left over, 63, yeah, because we only need 60, Stuart. So for the last one, we have to find a network big enough for 60 devices. So 5 bits. I'll give you a little spoiler alert. See how I've numbered the columns with the bits? If this is the 64s column, well, I didn't mean to do that. If this is the 64s column, I highlighted the whole thing. Never mind. No, I don't want to do that. I'll do it again. Come on. No. God, my mouse is killing me. No. All right, mouse. I use a keyboard instead. Stupid mouse. So this is a 64s column, right? So therefore, any combination of ones and zeros on the right-hand side will not be bigger than 64. So yeah, 63 is enough because that's all we need, because we only need 60. The diagram I deleted said we only need 60. All right. Now let's look at the mask. So if 2 host bits left behind, no, because that's 60 hosts. We don't need the +2. We just, because we said 60. So what's the subnet mask going to be for the 2/12 networks? So if why has it done this? Never mind. All right. Someone says /28. I'm pretty sure that's right. So I'm going to write it in because I'm very confident that it is correct. So what is so if we've got oops, put a space there. So /30 /28 for the 12s. So what's the subnet mask going to be for the next one? Hopefully you can see the pattern. Oh no, it's not 30 because we've already used the 30s. /27. Because remember, it's the amount of ones. The amount of ones from the left moving right. Don't know why this is. No, man, my mouse is letting me down today. No. Never mind, screw it. All right, just work with it. All right, and what's the last one? What's the subnet mask for the 60? Looks good. All right. So now I've calculated the masks. Now, if we want to do this in binary, then we've got all these zeros for the first network, right? Because we want to start at the beginning. So therefore, the network ID will be .0. The first usable will be .1. The last usable will be .2. And the broadcast will be .3. So, because we're doing it in binary, all of this is the same because we're not touching that. So we've got 0.0.0.0.0.1 because that's the next available number, right? So if the x's were zeros, that'd be 0, 0, 0, 0, 1, 0, 0. So that'd be .4. And then the lowest possible number with the x's is 0, 1. So 0, 0, 0, 0, 1, 0, 1 would be .5. And then 1, 0 would be .6. And then 1, 1 would be 7. So based on that logic, we have 0, 0, 0, 0, 1, 0. Oops, sorry. 1, 0, because that's the next one in the pattern, right? Because we've got all zeros, 0, 1, 1, 0. So what is the network ID of this subnet? What? If the x's were zeros, what's this number in? It's .8. Perfect. So therefore we've got .8, .9, .10, and .11. Now, you might think to yourself, okay, well, we've got to keep going here. So if we just go 0, 0, 0, if I make this a 0, what does that make the network ID for this network? If I just leave that as a 0. If I leave the first /28, if I leave that as 0, that's right. Can we use .0 for this network ID for this network? Just type a Y or an N in the chat if you think it's if we can or we can't. Okay, we've got one vote. Everyone else not brave enough to type? Okay, we've got a few N's, so that'll enough. I guess 2 will do. So we can't use it because, oh, thanks, X, Damien, well done. Is X a yes or a Y? So it has to be a 1, right? Because it can't be a 0 because .0 has already been used up. Because the number one thing that's going to cripple you with your VLSM design is overlapping host range. That is quite literally the only thing that matters. You can never have an overlapping host range. So therefore, we can't use all zeros here. It's illegal. So so if we can't use all zeros, this is the first legal number, 0001. Therefore, someone's already typed it in the chat. But that's correct. So what is the network ID for this network? It's .16. So what does that tell us? That tells us we've actually got a bit of a gap, because there is a .12 network in there, but we can't use it because this is not where we're using it. So the first available is .17. Now, I'm going to show you something that I'd like you to think about. We can sit down here and we can do some sexy math on what will be the last and what will be the broadcast. No, actually, we'll do it. We'll do it anyway. We'll do it. So if 16 is the network ID, 17 is the first, what's the last? No, it's a bit higher than 19. Someone else. Well, sorry, not someone else, everyone else. 22 is getting a bit closer, but still needs to be a bit higher. 29, not quite right. 31, not quite right. Okay, I'll give you a bit of a hint. It's an even number, people. Remember, broadcasts are odd numbers. Network IDs are even. Firsts are odds, lasts are even. So 30, let's see if 30 feels right. What we'll do is we'll go over here. So you can't see where my cursor is, can you? But we'll do this instead. 0. Let's look at the network ID for the next subnet. Whoops. So this is 32, right? So the next network is .32. So therefore, it can't be any higher than this. It's impossible. So from 16 to 32, because this is everyone happy that this is the network ID for 30. So thinking about that, let's actually do the math. Let's do the math. So if 0001 is 16, zeros. 0001, 0001 is 17. What is 0001, 1110? So we can do it Sheets way around. No, we'll just do it longhand. So what is, there we go, let's type it in the chat. What is 16 plus 8 plus 4 plus 2 equals? You guys tell me. People happy with 30? And so if 30 is the last, then .31 has to be the broadcast. And it's no surprise, because if you think about, remember like the old adage of a speedo, you know, if you've got all 9s and you add 1, it goes over to the thousands. It's the same with binary. 1, 1, 1, 1, 1 plus 1 clicks over to the next placeholder. So 0, 1, 0, 0, 1. So what is now well, let's do the broadcast first, because broadcasts are easier, and then we can just -1. So what's the broadcast for this address? If this is from 16 to 31, then this is from 32 to what? What's the broadcast address for this network ID? No network needed 13. There was 2 12s, a 28, a 60, and 3 serial links. Excellent. I'm getting lots of maths. Okay, so let's do old school maths. What is 32 plus 8 plus 4 plus 2 plus 1? Because that's the math we're trying to do. 32 plus 8 plus 4 plus 2 plus 1. Yeah. Dot 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. 49. No, that doesn't feel right either. The 47 feels right. Hang on, 38 plus 8 is 40, plus 7 is 47. It's 47. That's got to be 47. 38 plus 32 plus 8 is 40, plus 4 is 44, plus 2 is 46, plus 1 is 47. So therefore, this is 46. The reason why I know that is because 48 is one of those numbers. Remember I said your 8 times table and your 16 times table, they got off right. That's why 49 didn't felt right, because it was too high. All right, so can we use 0, 0, 0 for this guy? What would happen if I'm trying to make this network, this next network, 0, 0, 0? That would be no good, would it? It would be, yeah, it doesn't work. It's broken. So once again, what happens if I try to make this a 1? That's also broken, yeah? That's the original diagram. I thought I'd bring it back just for fun. So we can't use 0.1 either, can we? No, that's already been used. So the only available number we've got to choose from is that number there. So therefore, what is, yes, yep, absolutely, 0, 1, 0. So what is this? What is the network ID for this network? .64, fantastic. You guys are guns. So .65, whoops, 65. So once again, we'll work backwards because it's easier. So what is, all right, let's type it in chat again because I know you love it when I type in chat. So what is 64 plus 16 plus 8 plus 4 plus 2 plus 1? That's what we're trying to work out, isn't it? Now, see, that number feels right to me. Like I said, 96 is a good number for a network ID. So if you say the broadcast is 95, that's one of those numbers that feel about right. So can we use, whoops, can we use 0, 0 here? No, we can't. That's already been used up. You've already agreed with that. Can we use 0, 1 here? No, we can't use 0, 1 there either. So we have to have 1, 0. .128, thank you. And then .129. Now let's see how many people. Thank you, Alan. I'm sorry, Stuart. We're going to talk about that in 2 seconds. So what is 128 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1? Pretty sure it's .191. Excellent. .190. There you go. So there we have it. We have just addressed this entire network. So the 3 serial links, 1 and 2, 5 and 6, 9 and 10. And then the first .12 network is from 17 to 30. The second .12 network is from 33 to 46. The 28 network is from 65 to 94. And the big 60 network is from 129 up to 190. Now, everyone hold out your hands in the air like you just don't care, and let's do the masks. So 30, where can I do it? I haven't got anywhere to type. I'll type it over here, even though it's not technically in the right place. 245.245.245. What, by holding out our hands with the /30 for 6 bits, how many fingers do we hold up and we count in the air? Because now we're doing remember the hands? I did the hands, holding your hands in the air and counting out 6 fingers. 252. What is the mask for the /28? Whoops. So if it's 28, so we've got 4 fingers. How many is 4 fingers in the air? 240. Excellent. How many is 3 fingers in the air? And oops, make this a bit smaller. And how many is 2 fingers in the air? So that's it. So you absolutely write down the subnet mask, right? That is absolutely 100% sure. But eventually you're going to have to program your equipment. And when you program your equipment, you're going to need to write down you have to actually physically type in the mask. So that's why it's easy. You just look at the paper and say /28, 24, 25, 26, 27, 28, 128, 192, 224, 240. Okay, 240. Just type in 240. Do you know what I mean? So if you only write down the / notation, that's fine. Just as long as you can bring up your hands, bring up your fists in a peace sign, and count out and type that mask in every time. Now, someone very, very cleverly pointed out that this network has a whole bunch of gaps, right? Look at it. We've got gaps. We jump from 8. Look at the host ranges. We jump from 10 to 17. There's a nice fat gap in there. We jump from 46 to 65. We jump from 94 to 129. There's all this wastage, right? There's all this wastage, and this is the problem that that people do. So why don't we? Oops, hang on. Let me try and figure out how to make this work. Let's do it properly. So, clicking. Oh. So now, hang on, no, I clicked too far, didn't I? No, that's right. I'm on the wrong slide. Hang on, this slide. See, like I say, I'm used to doing this on the whiteboard. Okay. So now, as quietly pointed out by 2 people in the chat, this is inefficient. There's nothing wrong with it. It works, but it could be better. And the most efficient way to do it is to do the biggest first. So we got 60, then 28, then 12, then 12, then 222. Is that right? Is everyone happy with that? So we've still got 7 networks. I'll try not to screw up my formatting this time. So we've got 7 networks, and we've gone from biggest to smallest. So now, let's see who can remember from the previous slide. How many bits do we need to cater for a network that has got 60 hosts? Here I am, spamming the keyboard. I didn't turn on caps lock, but never mind. We don't care about that. What color was I using? I was using that, wasn't I? Oh, that's way too bright. I'll just use that. That's a nice color. All right, so, no, not 7. 7 bits. If we had 7 bits, remember about the playing cards analogy. If I dealt out 7 cards and you have to turn them over one at a time, back and forth, back and forth. All right, cool. So, excuse me, 28. Should be 5, I'm pretty sure. Then 12 was 12 4, I'm pretty sure. Oops, I made a mistake. See, this is why I do this in a whiteboard, because that way I can rub things out when I get it wrong. Okay, how's that look? Whoops. Fail at highlighting. Something wrong with my mouse. I don't think it likes me having 15 different things open on the screen at once. Okay. Does that look right? Is everyone happy with the breakdown of the host bits? I've just marked out the host bits because we already know all 0s is the network ID, all 1s is the broadcast address, and every range in between is the thing. All right, so let's do it. Let's do this. So 0.0. What's the slash for this? What's the mask? (24, 26) or you're both correct actually. Excellent. So the network ID is .0. The first is .1. All right, here's a trick question. What's the last? What is the actual highest? What's the host range for this bad boy? What's our host? And oh, it's just too high, Lana. Just too high. So that's a hint to everyone else. Yeah, that's so 63 is the broadcast. So therefore 62 is the host. Sweet. Now, if I went 0, 0, 0, we've got a problem, right? That's not going to work. So what's the next highest number? What do these 3 bits need to be in order for us to do this properly? Excellent. You guys are awesome. Or maybe you just studied. All right, so what's the mask for this bad boy? Slash what? Perfect. All right, so what's this network ID? Sensational. Now, here's the tricky bit of math. What are our two last numbers going to be? So what is 64 plus 16 plus 8 plus 4 plus 2 plus 1? We'll see. Yeah, that feels right to me. Does anyone else want to second that? Yep. Everyone happy with that? 94 and 95? All right, so now this, we've already gone 0, 1. So if we did 0, 0 there, that doesn't work, right? That's busted. But we can do this, 0, 1. Because what is this starting point? What is 64 plus 32? Pretty sure you guys are going to guess it because the answers are on the screen, because it's 1 more than the previous broadcast of the previous subnet. Thank you. See, this is why it's more efficient. Notice there's no gaps yet. We have not made a single gap. 1 to 62, 65 to 94, 97 up to the next block. Do you see what I mean? So starting at the smallest, there's nothing wrong with it. It works. But this is a more efficient way of doing it. 26, 28. So what is, what's this? 1, 3, 7, 15. What's 96 plus 15? Excellent. Does everyone see how I did a bit of a dodgy cheat there? Because I know that is 96 plus 15 111? I'm pretty sure it is, isn't it? Because see, I looked at the x's and I knew that 1111 was 15. So I just did 96 plus 15. So what do we got here? 0, 1, 1, 1? That should work, shouldn't it? Let's see if it does. So slash 28. So what's this number then? What's 1, 1, 1? So what's 32 plus 16? 64 plus 32 plus 16. What's that? That's 90 something, 100 and, oh, is it 100? No, not 127. I'm pretty sure it's 112. Once again, spoiler alert, it's +1 from the broadcast of the previous guy. And this is how you, this is how there's no gaps. It's super duper efficiency. But Michelle's already jumped the gun because this is 127. The broadcast address is if there are all ones. Because what we wanted to do is the first number we need to find is when all the x's are all 0. And the second number is what they are when they're all 1s. So if this 127, we can't do this, can we? Because no matter what combination of ones and zeros and ones and zeros and ones and zeros in here, it's not going to work, is it? Because all of those numbers are already eaten up by their predecessors. Can you see that? So if we make this 1, 0, 0, 0, 0, 0, that's our starting point. And then this will be 1, and then this will be 1, 0. Oops. Doing this on the board, so it's easier. So 0, and then 1. Okay, that looks right to me. How does that feel? So these are all /30s. And then we have, so it's 128. Therefore, this is, it's got to be 132. And this has got to be 136. Sometimes working on the network IDs, because now we just fill in the gaps, right? Does that make sense? Because 128, because that's 128, 1 all zeros. 128 plus 4 is 132, and then 128 plus 8 is 136. Or sorry, 132 plus 4 is 136. Because everything else should just fill in. So this is 129, 130, 131. Whoops. And then the next one. See, there's no gaps at all. 1, 3, 5. Oh man, well, that didn't work. Lag, I'm suffering serious lag here. No, but it's even there. Even when I do tab, it's still sometimes it doesn't work. All right, I'll try tab. 1, 3, 3, 9. Now, what would happen if I went 1, 0, 0, 0, 1, 1, 0, 0? What's that number? 128 plus 8 plus 4. This is how we check ourselves. This is how we make sure that our math is correct. You see, and there's no gaps. There's no, all right. So there you go. Wasn't that easy and fun and exciting? Excellent. You guys are awesome. So you know what this means? Thanks, Dennis. You know what this means? Let's do it again. So this time, let's take our math. Oops, no, don't click there. Click here. Let's take our math to the next level. So, what is it's all good fun. Like I say, I'm giving you the answers in fast motion. So over the next week, you can download the same document and do it all again from home. But I just want to prove to you together that it's doable. So let's work from biggest to smallest. 400, 200, 50, 50, and 222. Is that right? Everyone just triple check my work, make sure, because we're doing this together. We're pretending we're in a classroom and I'm drawing on the whiteboard. Excellent. So, how many bits do we need to cater for 400 PCs or devices? How many bits do we need? He says, wiggling his headphones because his ears sore. How many bits do we need to cater for? Oh, first of all, sorry, we've got to calculate 24. So what's 24 in binary? 24 in binary, 16 plus 8, yeah? Oops. Actually, I'll leave that. Okay. All right, so 400, 200, 50, 52. Okay, everyone says that's correct. So 24 in binary is 16 plus 8. And we've got a slash 22, which means we can't touch, we can't go beyond, because 22, because this is 24, the dot is 24. So we go back 2 and we get to 22. So therefore, all of this is fixed. We cannot play with it. So that's where our slash 22 is. So how many bits do we need for 400 PCs? You guys still haven't told me how many bits we need for 400 PCs. Yeah, I'm pretty sure it's 9. Someone said 7, but I'm pretty sure it's 9, because if we have 8 bits, it's 254. So therefore 9 bits is 512. So that's 510. So the first one, the first X is here. And then we go, let's see if that works. Come on, catch up, computer. So let's give this a nice pretty color. We'll do yellow this time, nice and bright. So this is, thank you, 255 plus 1 bit. So this is how many bits we need to cater for 400 computers. So how many bits do we need to cater for 200 computers? Oh, I didn't paste the yellow. I was hoping to paste the yellow as well. We need 8 bits, absolutely correct. All right, what do we got next? 50. How many bits do we need for 50? 50 computers. I reckon it's here. So what's that? 6? Someone else? Someone want to second my 6? Pretty sure it's 6. You probably hear me typing and then the lag of me having 15 windows open. All right, and then 222. Kapow. Okay. Does that look right? For which one? No, because that's what we're doing. This is what we're, this is, because this, have a look at the criteria says slash 22. So it's a slash 22. So that means that the beige is locked and everything after that is up for us to play with. So have we declared the host ranges? Is everyone happy with the host ranges? All right, let's just for fun, let's play with the subnet mask. So if we started with the 22 and we've got 9 bits here in the H, so what's our subnet mask for the first one? Slash what? Excuse me. $23, absolutely correct. So let's, now we always start with the biggest, so we just put a 0 in there, right? 0. So dot 0, oops, no. Now it's actually 24.0. Isn't it? Because now we've got, once you go past the dot, you have to include both numbers. 24.1. So now here's the kicker. What address would this be if, is that first one meant to be 256? It is 256 mathematically, but what we've done is we've gone back and put the dots back in after the fact. Now, Shannon, you are absolutely 100% correct, except you've forgotten one tiny little detail, that we didn't start at 0. We start at 24. So everyone look in the chat and see that Shannon's sort of given you the right answer, but we didn't start at 0. Almost. It's 25. Because look at the binary. 0, 0, 0, 1, 1, 0, 0, 1. Dot. 1, 1, 1, 1, 1. So it's 25.255 and 25.254. That's why the dots are really annoying, and they're hard to get your head around. But they're just those days when you have to. So, but see, now we've got a good starting point, and now we're not going to have any wastage. So we've already used the 0 network, right? The 0 network is completely chockers. So this, if I put a 0 here, that's never going to work. So if I go 1, 0, that works, right? So this turns out to be, whoops, a /24. And so what is 0, 0, 0, 1, 1, 0, 1, 0, dot 0, 0, 0, 0, 0, 0, 0. What happens when we convert that into decimal? So close, but they're all zeros, Shannon. So it's 26.0. That's the actual network ID of that 200 network. So what's the first usable host? 26 dot what? 26.1, 26.2, 54, and 26.255. You might think to yourself, Josh, you've left yourself nowhere to go. Well, no, you haven't, because look what happens over here with our next available subnet. It can't be 1 and a whole bunch of zeros, because that would overlap. But it can be 1, 1, 0, 0. Well, we've chucked the class. Sorry, question in the chat is, what class is this? This is a Class C network, but we've chucked the rule book out the window. Because what you do once you get into VLSM is the class system is no longer your restriction. You can eat into the class system and do, this is called supernetting. So we're breaking the rules on the class system. We're eating our way back into the boundary. So is everyone happy with the third subnet to say that 24.0 is missing? No, 24.0 is the network ID of the first network. So 24.0 is the first line. Can you see my mouse moving? No, I don't know. It is. It's 400 hosts. It is way too many. But this is what we're doing. So let's make sure we got the binary. So because we started with 24, I know what's missing. I know what's missing. No, don't do that. Because remember, this network started with 24. So because it starts with 24, we got to add on. We got to count the whole binary number for the second octet, and the third octet has to be calculated. So we started with 24. So we've got to add on we've got to start up. So the first line is 24 because it's all zeros, because all the yellow X's are 0, and the first network ID is 0, so it's all 0. So yeah, 24 was given. Yeah, we start at 24. And then the second line, we've got a 1 in the 2's column. So it's 24 plus 2. So that's why it's 26. And now on this line, we've got 24 plus 3. So what's 24 plus 3? Whoops. Yeah, actually, I'll get rid of that dot because the dot's annoying me. 27 dot 0. 27.0 and then 27.1. Haha, but how big is this? How big is this guy? I know what I want to say, but I want you guys to tell me. So what is either one will do, either the broadcast or the last. I'll just type in whichever one, whoever types in the chat first. Excellent. You guys are awesome. Yeah, it's 63 because that's how big the X's are. So if you look, I don't know if you can see my pointer. Can you see the mouse moving on the PowerPoint or not? Maybe I'll just have to. There you can. Oh, good. So see, we've got 1, 2, 3, 4, 5, 6 X's. So therefore, we've got up to 63 because no matter what we do with the 1s and 0s in these X's, it's never going to be greater than 64. So that's how we know that it's going to be 63 because 63 is the biggest number that fits 1, 1, 1, 1, 1, 1. 6 ones. 32 plus 16 plus 8 plus 4 plus 2 plus 1. That is 63. So therefore, the last usable host is 62. Because we've got to put both networks in there because this is all 192.168.27.62 and 27.63, etc., etc. So this has always got to be 1, 1, and now this guy can be 0, 1. Now, no surprise, guess what this is going to be? Absolutely correct, 64. Because there's no waste when you're doing it this way, remember? You feed it off straight away. When you start with the biggest, all of the host ranges, there's no gaps. So 27.65, and then what do we got here? 27.127, that feels right to me, and 27.126. Oops. Cool. All right. Everyone happy with that? So let's do the next one. 1. Now this can't be a 0 because we've already eaten up all of this. So we have to start here with a 1 again. So because remember it's got to be the, oops, hang on, something's gone wrong here. 2, there's a 2 missing. So this is going to be 27.128 because that's once again, it's feeding off, it's 1 above the broadcast of the previous one. And that's why calculating the first, the last, network ID, the first, the last, the broadcast address, that's why it's so critical because it's almost impossible to make a mistake because the network ID is always going to be the next one after the previous broadcast. 27.129, 27.130, 27.131, and therefore this guy, let me make this a bit smaller because it's in the way now. Oops. So this, actually let's just do this because I'm feeling lazy. Okay, is my binary math correct? Pretty sure it is. So therefore we've got 27.132 and then 27.133. Sorry. Press the tilde instead of tab. 27.133, 27.134, 27.135, And this should be 27.136. So does 128, what's 128 plus 8? Pretty sure it's 136, so therefore that's right. 137, 27.138, and 27.139. So let's make sure our math is good. 1, 0, 0, 0, 1, 1. So what is 128 plus 8 plus 4? Excellent. See, and that's how we self-check ourselves to know that the next one is going to be the next one. Do you know what I mean? So you always try and calculate out that sort of stuff. Shall we do one more, or you guys are your brains are fried and you need to have a coffee and a sit down and a sleep? I got one more lined up for you, which is the hard one, believe it or not. So these first two are meant to be pretty straightforward. So, all right, last one, and then I'll jump off, and you guys can all do your own thing. So these are the documents that are in the shell. I'll put them there this afternoon. I mean, there are other examples in the material as well. My mouse has just gone missing. No, we can't go to 20. No. All right, let me just go back. Now we can't go beyond because that's our limit. Because from 24 to 27 is our limit. Because it's /22, we can't eat back into those beige bits because they're locked out for us. So I've only got 2 bits to play with. So we've only got 24, 25, 26, and 27. They're the only 4 bits we can play with. 28 is in the beige, so we can't use that. All right, let's move this. Let's get the hosts in. All right, where's the biggest one? Who can see the biggest one? I can't see it. Oh, 120. 120? Yeah, what's this next? Next under that is 90? No, I think there's a 90 there. Then there's a 60. Then there's a 30. Then there's a 224s. And a 20. Hang on. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3, 4. Okay, that's it. Yep. 20 and then 2, 2, 2. Is that right? Yes, these are all routers. You can have routers with multiple interfaces. Yeah, big circle with arrows going in and out is a router. The black lines that look like a sideways capital T represent an Ethernet segment or a LAN segment, and the red squiggly lines represent a WAN segment or a serial link, which you can only have 2 addresses on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Looks good to me. Because we're routing. If we want to do switching, we'd use switching. But they can be layer 3 switches if you want, but this is a routing function. We're separating out networks with routers to keep these people separate from each other. Let's just pretend that the 120 is the sales team and the 60 is, or the 30 is the payroll team. We absolutely do not want the payroll people to be on the same network as the sales team. So we can't, we've got to keep them separate. Yeah, okay. Everywhere there's a black line like this, these black lines with the T, that's either 1 switch or 20 switches, it doesn't matter. We're doing an IP address design. How many switches they are, doesn't matter. We could do it with switches as long as they were layer 3 switches. And if the layer 3 switches, they're routing. So from a diagrammatical representation, we use a router because that's what it's doing. All right. Now, the first thing we got to do is 192.168.30.23. Hang on, my mouse is gone. I can't find it. Where is it? It's over there somewhere. Here it is. All right. So we got to figure out what 30 is in binary. Why is my mouse gone? There it is. Okay. So what's 30 in binary? It is 16, 8, 4, and 2? No. That sounds right, doesn't it? So 0, 0, oops, 0, 16 plus 8 plus 4 plus 2. Is that 30? It has to be, isn't it? Yeah, it has to be. Yeah. Yep. So now, but, oh, hang on, we'll get rid of that 0, so that's in the wrong place. And it's just, oh, my mouse, come on, mouse, come back to me. There we go, sorry. So it's a /23, so therefore the pink boundary is going to go here. What color did I use last time? I used sort of this weird orangey pink. So these are the bits we can't touch, is that correct? Yeah. So that's where our /23 goes. So what's the biggest one we've got? 120. So how many bits do we need to fit in 120? How many yellow X's do we need? Pretty sure it's 7. Oops. Let's make them bright yellow. Okay, so 90. How many X's do we need to fit in 90? I think it might be 7 as well. Is that right? 7 as well? 90, yep. Oh, that didn't work. The demo gods are not smiling on me today. All right, that looks right, pretty sure. All right, how many X's do we need for 60? I think we can just fit in with 6, right? 6 should do. Yep. Because we're just doing it on 60. All right, now 30, 24, and 24, and 20, I think they're all the same, aren't they? 4 X's will get all of them, won't it? 30, yeah, so... Oh, no, sorry, hang on, 4 or 5? 5, sorry, my mistake. Yes, 5. 5. So what do we got? Let's see if I can do this, see if my paste works. Shazam, it does. See, wouldn't this be so much easier on a whiteboard? Because then I could just scribble with all my lovely multicolored pens. Kapow. How does that look? Can I get an amen in the chat? Is that right? Excellent. All right. So, like I said, this is after you've done it like 50 or 60 times, you can just do the straight up numbers on the light blue. But for where you are at now, absolutely break it down into binary every single time. This is just what you got to do. So start at the bottom. So 0, 0, 24, 25. We started at 30, so it's still 30. So it's 30. 30 only has 31. Sorry, have I made a mistake? Yeah, but that's okay because it's 30. We've got 25 staff, 2 printers, and 3 security cameras, and then one IP address left over for the router. So 30 is fine. Absolutely, because we're based on this diagram. So look, I guess technically in the real world, you would if someone said they got 30 machines, you would try to cater for it. But we're trying to this is just an exercise in math at the moment. So when they say 30, go 30. But if you're in the real world, if they say 30, assume 100. You know, because managers always underestimate what they always tell you the wrong thing. All right, so Damien's already smashing out those answers. I hope some of you other guys get a chance to get in there as well. So we got 7 X's, so that's 127 is alrighty. So the answer almost answers itself because this has got to be a 1 to fit this bad boy in. So therefore, if the previous one was 30.127, what do you reckon the next one's going to be? I'm pretty sure it's going to be 30.128. That's right, Shannon. I knew what you meant. So 30.128, so therefore 30.129. 30. Oh, what's the top end? If all those X's were 1s, what would the top end be? So it's 1, 1. Not quite. That's where we started. Yeah, there's a 1 at the beginning, and then all those X's are 1s. That's what we're looking for. Now, this can't be a 0, can it? Because if that's 0, no matter what we put here, it's already taken up, isn't it? All of this range is already taken up. So now this needs to become a 1. And this can be 0. Sorry, I'm saying this, I'm highlighting things. You can't see me highlight them. So now we've used up all of the right-hand side block. It's completely full, right? Because we've gone all the way from 0 up to 255. So now, let me just copy this because this is important. Whoop. Come on, mouse, don't. I knew you'd do that. Dang it. Sorry. Try again. Is it going to work? Okay, yes, okay. So it is. It absolutely is. So the next starting point will be 31.0. Now, just while we're here, I've been typing in the mask, I haven't really been asking you. So what's the mask for this network, please? / what? It's 26, because it was because the dot is 24. The dot is 24. So if the dot is 24 and you move to the right of it, you got to add. If you move to the left of it, you got to subtract. Because we started 23. 23 is 1 less than the dot. So 24 is the dot, 1 after the dot is 25, 2 after the dot is 26, and so on and so on. Awesome. So 31.0, therefore we got 31.what for our first usable host. That's an easy one, so I'll write down 1 because it is. It's 1. So, and I might just do one little thing just to make our life a bit easier. I might make them go like this. And someone's already big bold, Stuart, because that's right. It's 31.62 and 31.63. Absolutely correct. Oops. So now this is a 1 here. 0, 1. Because this can't be a 0. Because if that's a 0, that overlaps with the previous range. It has to be, no, it can't, unfortunately, Shannon, it can't be 1001 because that one is underneath this X. So therefore it's inside that range. So it'll be in that range, and we can't have it. So it's got to be outside that range. So therefore, it's got to be what it is. So therefore, what's that? That's 31 dot what? The answer's already on the board. I know the answer. I know it's not a board, but you know what I mean. 64. Because remember, when you start with the biggest and work to smallest, there's no gaps. No gaps. And the broadcast address for the previous subnet was 63. So therefore, it has to be 64. 31.65. How big is this going to get? What's 64 plus 31? That looks right to me. Dot 94 and 31.95. Now, do you all understand why I said what is 64 plus 31? Because that's the x's. Because in binary, 11111 equals 31. Whoops, 31. So therefore, if the if we've started at 64 and we add on 5 ones, then it's 64 plus 31. 64 plus 31 is 95. That's the broadcast. That's the highest it can possibly be. So once we've worked out the broadcast, we minus 1 and we get the last usable. And we're good to go. So 1 tab 0 1 1. So this is what? 31 dot what? Spoiler alert, what's 64 plus 32? It is absolutely 96. No. Absolutely. But I want one question at a time. So 0, 0, 0, 0, 0 equals 0. 0, 0, 0, 0, 1 equals 1. Sorry. 1, 2, 3, 4, 5. 0. 1, 2, 3, 4, 1 equals 1. 1, 1, 1, 1, 0 equals 30. 1, 1, 1, 1 equals 31. 5 bits, 2 to the power of 5, is you use, if you have to count from 0 to 31, you use 32 fingers. So if you have to count from 65 to 94, you use 30 fingers. So if you hold up your fingers and you say 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94. Okay, I lost count. Never mind. But that's the philosophy. So yeah, 5 bits. 2 to the power of 5 is 32. So minus 2 gives you 30. So it's definitely every combination of 5 bits. 5 bits is definitely 30. Now, as far as the subnet mask goes, it is, yes. So, okay, with the subnet mask, there are 2 ways of doing there's 2 ways of thinking about it. The subnet mask equals the number of ones in mask. So, but you could do it backwards as well. You could always say 32 minus host bits equals mask as well. So that if you look at the diagram, 32 is no bits at all. So if we've got 5 bits, what's 32 minus 5? If we've got 8 bits, what's 32 minus 8? Well, we don't have 8, so we've got 7 bits. So the top one's 25 because 32 minus 7 is 25. The third line is 32 minus 6, which is 26. Then the next line is 32 minus 5, which is 27. So the subnet mask is the amount of ones in the amount of ones in the network portion. So if we count up all the ones from the left, they stop once we get to the yellow X's. So that's what the /27 means. It means the number of ones in the mask. Yes. All right. Now, where was I? Okay, so 36. So therefore, 31.97. So what's the biggest number? So what 31 dot? What's the broadcast for this network? All right. You guys are killing it. Perfect. 1 tab 1 0. Because have a look what's going to happen now. We've got 31.128. Once again, exactly one more than the previous broadcast. So how big is this bad boy? What have we got? We got 15. No, sorry, 31. So what is 128 plus 31? Now that feels right. You know why that feels right, Helena? Because 160 is a good number. Because this 1 1 0 1 because what's that? 128 plus 32. What's 128 plus 32? 128 plus 32 feels like 160 to me. 160 is one of those good wholesome sort of round numbery, one of those good binary numbers, one of those numbers that sort of feels right. 61, 31. All right, where's this bad boy going to stop? So what is 160 plus 31? Exactly correct. Because look at what's going to happen over here when we start. Okay, this can't be a 0, can it? I can't put a 0 in this column because that's already been used up. So that has to be a 1, and these have to be 0s. So what is 128 plus 64? Exactly. And like I said, the answer already on board because it's +1 from the previous oops. 0, 1, 0, 0. All right. And it is. It absolutely is. All right. Did I make any mistakes? And that's why the host range, and this is why I started with the host range in the previous presentation, because the host range is everything. Calculating that host range is the starting point. And that's why the very first thing we started with was a whole bunch of big yellow X's, because we needed to know which bits are the representation of where the hosts can live. Any questions? All right. Yeah, that's all the actual presentation I had today. Like I say, in the shell, there's this exact lab. There is that 50-page VLSM document. There's also the let's have a look at the shell. Let's make sure I'm not telling you some lies. Now I had a Kahoot plan for today, but I've been pretty much, you guys have been super duper hardcore, so I didn't want to overload you with stuff. But if you could do the EOP, absolutely. If someone, in fact, I had to do this for our Lilydale site. I did it in Excel though. I went into Excel and I put down 10 in a whole big column, and then I put down 0, and then the cell underneath that I said equals the above cell plus 2, and then I just highlighted the whole thing, and then I put in the next column, and then I used. Oh, sorry. The question was. Sorry, now I've got 2 questions. Michelle's asked me the same question twice. So if your supervisor came and asked you to, you would do this. Do it in binary. They would come and say, I've got. Okay, we're building a new building tomorrow. It's going to have 8 classrooms, 2 staff rooms. It needs wireless and security cameras. So you need to count up the amount of classrooms, see how many hosts you need, count up how many staff. So maybe you need to cater for 200 PCs in classrooms. You need to cater for 20 staff. You need to cater for 50 security cameras, and you need to cater for 12 wireless access points. Go. And that's what we've just done. We've got a block, and we've got 200, 50, 30, and 12, whatever it was I said. And that's happened to me because we, sorry, Stuart, hang on. But does that, one question at a time, sorry, Michelle, does that make sense? That's the philosophy. So for example, out of Lilydale site, they built a new childcare centre, and thankfully I had enough VLANs to cope with it, but it could be literally like that. Here's a new building. It's going to have the HR team. It's going to have 10 people from HR, 20 people from finance, 50 people from sales, and you're going to have 10 access points and 9 security cameras. You just write down all those numbers. Say, okay, chop, chop, chop. This, subnet, done. Exactly the way we've done today. All right, we've still got a binary issue, so let us hang on. Sorry, this is so long I can't even read it. Okay, I've got a question in the chat saying got a question about, do you actually do this in the real world? Like I said, the answer is yes. When we took over the Lilydale site, we had 3 big buildings. Yes. No, okay, that's what I was saying. So how can I do this easily? I'll do it in PowerPoint because the PowerPoint's already there. I'll just do it in the PowerPoint. If I go to the next slide, is anyone feverishly writing this down or taking screenshots of this? All right, I'll leave it up there for 2 seconds, and I'll move this out of the. I'll move this out of the way. Well, this one. Come on, change, silly. Okay, so here, this is what I did out at Lilydale. 10.x.y.0/24. So this is what people do in the real world. So it's a bit hard to see. I'll try and make it a bit bigger. I'll make it blue. So 10.x.y. No, not red. I've already used red, you idiot. Green. So here's what to do. So I've got a new building. It's I've got a couple of new buildings, and each building's got 3 floors. And each building has to have networks for students, for staff, for CCTV, and for wireless. So I say that X equals BBF. And I say that Y equals VLAN. Now you might think to yourself, what the hell does that mean? Well, if I'm in building 4 and I'm on the 2nd floor, then X equals 42. So, and VLAN 10 is my Wi-Fi VLAN. So now I have 10.42.10.x/24. Done. This is how you subnet when you can. When you've got a greenfield, like when we bought out the Lilydale Lakeside site, I was tasked with addressing the whole site. I had 1, 2, 3, 4, 5 buildings. 3 of those buildings were multi-floor, and each building I needed at least 5 to 6 VLANs. So this is what I did. I just said 10.x.y.0, and therefore, so X, so if building 4 is, let me make it smaller. So if, let's say I'm in building 19 and I need, so building 19 and I'm on the 1st floor and I need to be doing the student VLAN. Done. Can you, so that this is, you need, all you need is a pattern. So this is how you do subnetting in the real world when you've got space. But here we're doing it in binary because we don't have the space, because we only have, we didn't plan, we only have 192.168.30/23 to play with. So we have to chop it up. But when you've got a greenfield site, when you've got a site that's brand new, this is the sort of thing you can play with. Because we want you to be able to fly before you can crawl. The question was about, I'm hoping you can all read the chat as well. You need to know subnetting because you're always going to have, but you need to understand the philosophy of why you're doing it. Once you understand the reason why you're doing it, all you have to do is just do it in binary. Because I literally, this 10.x.y, that's still in binary. I've just been lazy and I've made the binary match up with the dots. But it's still, the philosophy is still the same. Use Python. Well, actually, yeah, I'm actually trying to learn. I'm teaching myself Python at the moment. It's a pretty funky subject, but it's not too bad. Now, there's another question that came along just while we were chatting about this, still about binary. And where is it? No, Stuart, sorry. You said 31 minus 2, but it's not, it's 32 minus 2. So 2 to the power of 6 equals 32. So is that right? Have I just had a brain fade? My brain stopped. I'm sure you guys are all brains. 2 xy 6. No, it's 5. I'm sorry, made a mistake. 2 to the power of 5 equals 32. So therefore, to generate hosts, it's always 2 to the power of h minus 2. So therefore, 32 minus 2 equals 30. In fact, if we go back to, did I do it? No, I did in the other one. Where's the other one I had? That's this one. What happens if I do this? Is it going to break everything? Yes, it does break everything. Sorry. Sec. Oh, no, stop sharing. What can you guys see? Oh, no, you can't see that. Share. That one. There, so this is the presentation. This is the dodgy thing I did as a quick summary towards the end. So 3 bits borrowed, 2 to the power of 3 is 8, and that leaves 5 h's behind. So 2 to the power of 5 minus 2 is 30, because 2 to the power of 5 is 32. And 2 to the power of 5 minus 2 equals 30. Well, it's because you can't use the first, you can't use the last. Yeah, it's just one of those rules, because the first is always the network ID and the last is always the broadcast. So a lot of students actually have given themselves a little sort of a thing. Actually, let's see if I can do it. What can I do quickly and easily? Come on, Excel. Maybe I'll do it in Excel. So some students sort of, because your journal has to be handwritten. So if you do 1, and then you do, hang on, no, we'll do this. We'll do subnets, and then we'll do, no, I can't do it there, sorry, we'll go do it here. We'll do subnets, and then we'll do hosts per subnet. Oh, no, that's right. So 1. Fill. So we do equals. God, what is it? I've just realized I don't know the XY formula for this. Does anyone know what it is? I'll see if that works. Oh, that didn't work. Okay, there we go. And this equals this minus 2. So that's, I don't know if that, can you guys, can you actually see that on your screen? Is that actually seeable? So that's the formula, because the formula is 2 to the power of for subnets and minus 2 for hosts per subnet. So for every time, so 2 to the power of 4, 2 to the power of 2, 2 squared is 4, 2 cubed is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6, and so on and so on. But it's always minus 2, because you can't use the first and you can't use the last. Put that over there for a second while I bring up the chat window. Yeah, okay, awesome. Yeah, so like I say, a lot of people in their engineering journals just do this chart up to maybe 10 bits just for fun, or maybe even 14 just for fun. So this is just to the power of. So it's 2. Whoops, no, don't do that. 2. So 2x. Yeah. Where this is x. This is just a little formula you can handwrite into your journal if you want to help you with your subnetting. So just help you with your math, because sometimes it's because sometimes a lot of people do, and I do this as well. Whenever I'm doing any binary at all, I just do an absolute brain dump, and I just do 128, 64, 32, 16, 8, 4, 2, 1. I just type this out because I know that I'm going to have to do some math, and this is just like placeholders, and I know that that's what I have to, that's the math I have to work towards. And I sometimes even, like I did it today, hopefully that it sort of worked, I color code them in nibbles as well, so that you know. My mouse is really letting me down. This doesn't like me sharing. No, it's not going to do it. Never mind. But that's just a little helper, because whenever you're doing maths, you need the columns. So if someone says, "Oh, figure out the binary for you know, come on, for 0, 0, 1, 0, 1, 0, 1, 0." You know, someone says, "Figure out that, convert that binary number." Well, that's just 2 plus 8 plus 32. So 32 plus 8 is 40 plus 2 is 42. So that equals 42. So just to have your little chart that you can refer to. Well, there is, but see, there's always going to be times where you're going to be, like I say, I've said this to my other group a lot, because I get this question a lot in the second 991 group, which you'll be doing later on in the year. They ask me the same sort of question and say, "Josh, why are we doing it this way? Surely there's a better way of doing it." And I say to them, because there's going to be a time when you are sitting on the floor of the server room in the data center with a laptop with a console cable plugged into a console of a router. There's no internet because the internet's down, because your job is to fix it. So you have to be able to do stuff without access to the internet, without access to Google. Just a notepad and a calculator or a pen and the back of an envelope. Well, you can't see that because it did the thing. Just you got to sort of be able to do things not off the top of your head, but you know, a pen and paper, scribbling down, or open up Notepad, or just to do something, because you're not always going to have Google. You're not always going to have stuff. Yes, as Michelle says, because hopefully you're getting paid to. You're doing it this way because you're getting paid to do it that way. Yeah. All right. Look, it's 5 o'clock. I think it's time to give my voice a rest and to give your eyes a rest. So get yourself a cup of tea and a bicky again and come back. So if you look in the shell, there's stuff to do with, so there's this exact exercise we did. I've actually given you the answers for the VLSM worksheet. That's what we actually did. And so later on tonight, after dinner, if my voice holds out, I'm going to try and record those. I had no idea that it would take so long, so I might have to speed it up and put it on the internet. But you guys have seen it live, so you've got it live. But there's worksheets. So the worksheets for today are quite literally binary math. So we did it all together, and you guys are awesome, because you guys are giving me lots and lots of feedback, and do it. So next week we're going to be looking at dynamic rating protocols and have a bit of fun with that. I've already put a few YouTubes up on that, and I'm going to, between now and next week, I'm going to do one on IPv6. So you can have a bit of play with IPv6, but once again, don't be afraid of IPv6, because no one's ever going to give you the full 4 blocks. They're going to give you 3 blocks or 3.5 blocks, and you can just say, right, well, here's a whole block. So just change the numbers and you're good to go. Just make them up, because you don't really, no one ever goes past 64, because it's pretty much been illegal. So you got from 64 to 48, and all those bits are yours to play with. So yeah, so don't be afraid of subnetting IPv6. It's just, you're given 3 blocks. Oh, there's a 4th block. Just go 1, 2, 3, 4, 5, 6, 7, 8. Done. It doesn't matter that there are 65 million hosts. It's just that you're just chopping it up that way. All right. So I'll stop sharing my screen, and I'll put on some background music. I'll stay here for chats, of course. Just let me, what am I doing? Stopping sharing my screen. So thanks for watching. Please remember to subscribe, click the notification bell. If you enjoyed this video, give me a thumbs up, and leave me a comment with what you'd like me to make for my next video. I'll see you in the next one.